All right. Welcome everybody to our tech update. This is a special one, the sprint review of the platform teams, and also we're combining with some tech update from various teams because this week we had kind of a hackathon week in Tbilisi, Georgia. And we would like to show you some discussions, some results from those as well. So it's going to be a little bit mixed, but hopefully it will be a nice finish, nice nice way to close our meetup week this way with you. My name is Balázs Bézi. I'm supporting platform teams as a Scrum Master, and trying to help the team to get their best results. Basically, we are planning this session for 1.5 hours. It also depends on your questions, which I encourage you to leave comments, leave questions in the live chat. And the end of this session, we are trying to answer those in a Q&A session as well. All right, without further ado, let's start with Tender Dash team.
Hello, everyone. My name is Dmitry. I'm software developer at Tender Dash team. On the past sprint, we worked on implementation of same block execution, and well, we're going to do it probably 2 more sprints because currently we're working on stability of that, and we already delivered. But despite on it, we already delivered one unstable version, which we call this alpha. And we did especially for protocol team in order to start working on integrational same block execution. Well, for those who don't know what is a same block execution, and probably somebody forgot what is that, I just wanted to explain quickly. So first of all, Tendermint has next block execution approach, which is completely different because of next block is assumed every committed block, for every committed block, app hash of that block will be appeared in a chain only with the next block. What is that? It means for every block we have to wait one more block in order to get app hash. So basically, same block execution solves this problem, and one of that problem which same block execution solved, and one of the achievement we want to reach. So we reduce amount of generated block. We also reduce resources which we need to consume and other stuff which related to producing block and execution one. Well, yes, already mentioned, we're still working on this task as implementation already done, and currently we're focused on stability. Second topic is P2P investigation. Some time ago, probably several weeks, I don't remember when it was, but Tendermint decided to discontinue V035 and V036 releases because of they found critical bug for them, and they rolled out to version V034. And since we already backported both versions with fast critical modifications, and we decided to stay on that. And yeah, currently we started working on investigation and solve that issue by ourselves. And currently working on reproduce that issue, but fortunately I found the issue on Tendermint board where they they mentioned that bug reproduced only when some node worked as with a legacy approach, and some not work with a new approach of P2P. So basically, that is the reason why they got that back. We don't have legacy at all, and we work only with a new version of P2P. And fortunately, we don't need to care about that back, I hope. But we should kind of do some checks by ourselves before to confirm that. And the last topic is backport to Romanian code base. So it's kind of pretty straightforward. We already backported the code, and we worked on to merge that backport with quite modified code base affected by some block execution. So basically, we already kind of merged both branches, and version v010 branch already contains both of them. What's next? We're going to work, as already mentioned, on stabilization, some block execution, and still going to reproduce P2P issues that would be possible for us. Thank you for attention.
Thank you, Dimitri. Let's move on with GrowthDB.
Hey guys, my name is Wisdom from the GrowthDB team. So this sprint was quite slow because I had to take a break for a week. Evgeny is working on bindings and Sam is dealing with management tasks. So one of the features we're working on is on sum trees, which basically allows you to create a Merk tree that sums the value of the individual nodes in the tree. We started work on this before, but then we had to drop it because of other higher priority tasks. So I've picked this up, and I'm going to complete it basically. So we have a PR that had most of the feature implemented. So it's just to fix the issues and then extend it to become feature complete basically. So that's still in progress. I'm going to pass it to Sam to talk about cost.
Yeah, thanks a lot, Wisdom. I just wanted to add really quickly what it means for the sum trees. The sum trees are a cool feature because they'll allow us to verify that the total amount of value inside of platform is equal to the amount of locked dash inside of platform. So it removes any type of issue with inflationary bugs that you see in a lot of other projects. I mean, who knows if it can also be broken through a very convoluted way, but as I see, this is pretty it's like two-factor auth that a lot of people use. It's like you verify it one way, you verify it a second way, reduces a lot the risk that there will be a problem. So I'm very excited that we're going to have this for our mainnet release. Okay, so the next thing that I wanted to talk about is the storage flag system. I'm going to go quite in detail on this in a future slide. So right now, let's put that on hold. In the last sprint, we had talked about what was next, and we said we're plugging in the system into RS Drive. So we did that. Then we fixed all of the bugs of using this new system that we had built the previous sprint, and there were a lot of issues by plugging it in. We haven't yet completed that, so it's just like an in-progress item. Forgot to write in progress, but. And as always, we're continuing on costs. The inserts had been done quite a long time ago. For updates, we have a lot more work on updates that have happened. The just-in-time updates were improved after they were integrated into RS Drive. Deletes are there. However, I do believe that there's going to be more work there because we haven't yet written the tests for deletes. So we definitely will have issues. Batches seem to be working now. I mean, the cost for batches seem to be working properly now. And I'm going to talk about that in the next slides. So let's go to the next slide and I'll start talking about storage flags. So originally, we basically just kept in every element the epoch that the item was inserted. And then when you would remove that item, you would get value back to your identity based off of the initial epoch that it was inserted. Obviously, that sounds like a great system, but when you build it out, you realize that there were some things that you had forgotten. And one of those things that we've forgotten was when we'd update things. So when we update things, what really happens? You can either have something gets bigger, something gets smaller. And I mean, for example, let's say you have in platform a contract around cars, and you had a red car, and then you update the color in the system and you go to orange. Now, red is 3 characters long, so it would take 3 bytes, and orange is ORANGE, 6 bytes, 6 characters, so 6 bytes. So you would be adding 3 bytes by making that change. Let's imagine that you had originally inserted this item at epoch 0, and then you're going to insert to make the update and make it bigger by 3 bytes, but much later in the system, like let's say around epoch 10. Well, if you were adding 3 bytes and you were adding it as if it was on epoch 0, it would actually cause a problem in the system because that's not the price that you should be paying. You should be paying it for your current epoch. So we added storage flags to allow for decomposing the amount of bytes stored into multiple epochs, and also to signify who owned the bytes. So basically what happens is if you, well, actually we can go to, I think the next slide explains this a little bit more. Yeah, so when an item is updated, you have 3 scenarios. The item could be of the same size, so there's no change in bytes. The item could be bigger, so you could, if let's say the first item was inserted at epoch 0 and then updated at epoch 0, there would be no change because it basically would signify the whole amount of bytes are from epoch 0. Let's say then it was updated again and added 3 more bytes at epoch 1. Well, you would say the majority of bytes are on epoch 0, and then you have 3 bytes from epoch 1. Yeah, so that's basically what happens when you have something bigger. When you have something smaller, it gets a little bit more complicated, meaning that you're removing value from the system and you're taking it back to yourself. This basically, we use last in, first out as a way to remove bytes from the last epoch. So you'd always get, so let's say you added 3 bytes at epoch 1, and then you remove 3 bytes at epoch 2, you would be taking the 3 bytes of value from the last epoch that has bytes inserted. And then this is transmitted back, and then your account is recredited. And this is basically so somebody with frequent updates to their system, like adding and then removing, adding, removing, adding, removing, basically doesn't have that much fees. So we want to create a system where, you know, you could play a game and you could be constantly adding data to the system, constantly removing your data, and you actually just pay for your storage that you have for the amount of time that it was in the system, not for perpetuity. So it should work a lot better than other solutions on the market. And I think that a lot of people will be very happy with the quite low costs involved around, you know, doing things like playing a game, or, you know, many applications could, you know, store user information just for the amount of time that's really needed to be stored, but it would be very, very cheap. Excellent. Okay, so next one. We did have one big problem that took some time for us to solve during this sprint, And it was around when we add a non-root value, the parent will be modified. So let's imagine you have a node in your system. The node itself is owned by, let's say, Sam. And then underneath, this is a very technical idea, but underneath any node, you have your left element on the tree and your right element on the tree. And both of those left element and right element, they basically have a reference to the actual value. And these references take space. Now, if your left element was removed from the system or added to the system, you don't want the parent element owner to pay for it. You want you to pay for it. You're the one doing the action. And this was kind of causing some issues for us because we hadn't really thought of this. But now we have, and it's basically it's an easy solution. The node that you add, let's go to the next slide. The solution is basically that the client pays for one parent reference, because any one element in any information in a binary tree only has one parent. And since the child node knows the size of its key, the child node can pay for the parent's reference to itself. And basically we solved that problem. So, you know, it seemed very complex, but in the end, a simple solution was found and has been implemented. So that's one thing out the way. So what's next? We are continuing making changes and verifying changes with RS Drive. We had talked, normally these two items should have been in our sprint. Sadly, we just did not have time to do them because we had found other issues. So basically deletes and updates, making things smaller. We need to remove the costs from epochs, and then the return costs need to be given back to users. We still haven't done that. All we do right now is we say, hey, you need to remove costs to RS Drive, but it just doesn't do it yet. So that's for next sprint.
All right, thank you very much.
Mm-hmm. And with that,
see.
I will pass it to Igor.
Yes.
Thank you, Sam. Hey, everyone. My name is Igor, and I'm a lead software engineer in JavaScript SDK team. For those who don't know what I do, I would explain it simply in a few words. I'm trying to bring Dash ecosystem into web browsers. The goal for the sprint was the same as the last one. We continued reworking chain synchronization process in wallet library, and we managed to do quite a lot. So we finished with the adapting new logic to existing tests and workflows with platform. And basically, we finished the storage solution. We refactored storage solution for wallet. We made QA and peer reviews of the pull requests, and also finished with all the unit tests. So as a result of all these efforts, I would like to make a short demo. And I'm sharing screen right now. So on the screen, you see my favorite TV shows service I use to watch movies and TV series and etc. And on Monday, it occurred that my subscription has expired. So I proceed to payment, and I saw crypto button. Okay, let's see what we have there. Some coins, and boom, Dash. So that was the night. I was super tired, and I didn't have my mobile Dash wallet with me in my bed. So I was kind of frustrated that we don't have a browser solution for paying in Dash. And even though DAPI and the whole screen is the whole thing is not on mainnet, the least I could do is first prepare a friendly and well-known demo environment, which every Dash user is aware of, and build a foundation for something that could really become a production-ready application. So that being said, I'd like to demonstrate to you Dash browser extension I've been working on this week. And I'll show you how the synchronization process works in it. So I already pre-synchronized a couple of, not a couple of, half the chain, let's say. And here you can start, the chain started synchronizing and we start receiving transactions from the chain. This is a test wallet from Mobile Team and it has quite a lot of money there. So in a couple of seconds, we should see balance changes and so on and so forth. For now, I disabled receive and send buttons because I added them just to be more consistent with the mobile apps. But the actual functionality will be topic of the next demos. So we got some transactions here. Let's refresh the extension and I will demonstrate a storage functionality, but we have them in the wallet storage. Turning off back. Some time to pick from storage. Yeah, here we are. Here is our synchronized balance. And in a few seconds, we should start syncing that again. Yeah, there it goes. Here is the whole list of stuff we have. There's quite a lot. I think this wallet has 700 transactions. But yeah, we won't be waiting for that. Let's just see how quickly and how rich I am on the testnet. Apparently, this wallet used to test masternet functionality or something like that. So yeah, this is basically it. I want to thank everyone who helped me in this endeavor. I spent about 2 months in a cave. I was doing all the stuff myself. And finally on the meetup where we all gathered together, I managed to involve other people. And I think I worked closely with 6 or 7 peers with across all the teams. So yeah, this is it.
Big round of applause.
Yeah, congratulations.
Thank you. Congrats. Thank you. This is awesome. All right.
I have a quick question for you, Igor, if you don't mind. Mm-hmm. What browsers does it work on?
Currently, it's actually cross-browser framework, but I haven't tested that in Firefox yet. So for now, Chromium only based. Mm-hmm. And for the next demo, I will try to make an exchange, send and receive transaction between Chrome and Firefox.
Cool.
Did you use the incubator repo with this extension, or something that you made from the scratch?
Can you say again, please? You're echoing a lot.
Oh, sorry.
No.
Are you?
No, it's good.
Is it continuation of the work what the incubator started on the extension, or it's something from scratch?
No, it's from scratch completely.
Cool, great.
Thank you. Oh yeah, I forgot to speak about what's next. Yes, so the next thing would be the test platform. This week with the refined wallet synchronization logic on testnet, and the Superbus consensus rules and reorgs. Yeah, that's it. Handing over to protocol team.
Sam, do you want to say something else?
James Doe said, Dash keeps you locked in a cave? How terrible. And the answer is yes, we keep everybody locked in a cave until we ship platform.
Preferably everyone in one cave.
Oh yes, with no air conditioning. Well, I don't think you need air conditioning in a cave.
All right. Protocol. Javid, would you?
Javid, you probably start.
Yeah, sure. Hello, everyone. Javid here from Platform Team. Quick update on withdrawal and withdrawal queues that we've been working on this time. So we're had a discussion with guys about some changes in the logic recently, and after that kind of merged two stories of implementing the queues and signing of withdrawal transactions as one. And the logic is complete, and the only thing left is polishing PRs and writing tests for it. So this is being done as we speak right now. So I hope we'll finish it soon. And that's about it, about the withdrawal queues. Kevin, could you go next?
Thank you, Javid. So yeah, during the meetup, we finalized design of asset locks and accomplished the planning of the whole epic. Yeah, so we also worked on BLS BLS signatures binding for Rust. It seems like there's a mistake in the slide. It should be like Rust binding. The binding itself works now for Rust, but we need to make sure. So basically, they have this library. It's library written in C++. We use it in the core, and we want to use the same. Yeah, thank you. We want to use the same code base on our other components, and we already have the binding for JavaScript, what we're using in our JavaScript components, and we need the same for Rust. And that part is done, but we also compile our Rust components to the WASM in order to replace JavaScript components. Specifically, I'm talking about DPP. So right now we're working on like WASM version of DPP, and Anton will talk about this in details. But the point what I was going to make that we need this binding to become like compilable to WASM as well, since it will be used in WASM DPP. And this is kind of tricky, having like all the dependencies there, and we're still working on this. Mainly Evgeny this sprint needed. Yeah, so we'll continue this work. Also, you probably noticed that we have some issues in inside and inside components, such as inside API. And this issue is Dash Central. It didn't work for some time. And it was, the reason is like incompatibility of the transactions between the core 17 and 18. And this component, the inside wasn't updated for a while. So this week we updated all components, and all the, I would say, the all frequently used functionality tested, and it works well. We know about some minor issue, and together with incubator, we're fixing it right now. So we should expect all inside to be working soon, only for testnet, mainnet, and devnets. Next thing, our teammates from the core team released the new version of the core, like 18.1. It goes with new features required by platform, version 24, including the asset logs and other stuff that we're going to test and integrate. So we integrated this basically we updated the core with changes. We did include some breaking changes, so we had to update the platform, and now it supports the new alpha version. So we can continue development of the features was dependent on this new version. The next topic is multi-transaction support. So let me explain what does it mean. Tender Dash team and Dima already told spoken many times about the same block execution. So we can, so instead of like execute an block, basically, no, it's not like that. So instead of provide the cryptographic signatures on the next block, because we will do that and calculate them for the current block. So we're reducing the number of removing this extra block for confirmation. And for this feature, we need to be able to apply state transition to the state without actually saving this data on the disk. So it's more like the ephemeral computations with GrowthDB and RocksDB underneath. And to do so, we use the RocksDB transactions. And for now, we have only one. So we limited this in Drive and JS Drive for simplification. But with semi-block execution, it's possible that you will be able to create like multiple blocks for the same height. And one of these blocks will be eventually applied. So basically, you need to create apply multiple blocks to the state without saving. And when our validators vote on one specific, we need to take one of these basic transactions and apply it to the disk. So we have this functionality already in GrowthDB, but we don't have it in Drive, in binding on the on Rust side and in JS side as well. So that's what we're working on right now. It's like preliminary work for same block execution integration, which we're gonna start soon. Balázs, could you switch to the next slide? Yeah, thank you. Kostya, would you like to talk about the
sure.
FDAPI?
So my name is Kostya and I'm platform software developer. So as you probably know from our previous reviews, we started implementing SSL support in the platform. So as you probably know, the browsers are trying to move from HTTP to HTTPS because of the security reasons. So did we. So at this point, we implemented SSL support for the client, both JSON RPC and gRPC protocols, and gRPC web as well. You can use self-signed certificates for the local development. You can use your own certificates, either your own certificates or certificate provided by Zero SSL provider for your testnet node. We support only Zero SSL provider at the moment to obtain new certificates, but we will probably support more providers because it's not super hard thing to add. Yes, and you can renew your Zero SSL certificate when it's before it will be expired, because The free version only allows you to use 3-month certificates. Yes, and right now we are doing, let's say, a tool which will renew 0SSL certificates automatically before they expire. So the process will be super smooth for the user, and you don't need to worry about certificate expirations. That's basically it.
Yeah, I would thank you, Kose. I would like to point that using 0SSL is not mandatory. You can also use your own certificates, and like when you are in different providers and set them manually when you do Dashmate setup and you configure the node. So you have a choice. Thanks. And we continue to work on the fee system, and Sam talked about this today, and we also continue work on the withdrawals. So there are some after the withdrawal queuing, we're gonna work on the signing of withdrawal transactions. We also update some documentation. We need update the asset log functionality, that basically the funding is going to be changed to reflect the final design in the document. And good luck as with the last bindings, and I hope we will find solutions soon for that. And as Kostya said, we still have one task for HTTPS for DAPI, and it's going to be closed soon. And we are preparing right now for same-block execution integration. Multi-transaction support will be done in JS Drive, and in Binding of First Drive, we will start to integrate same-block execution with the Tender Dash team into Drive. And we made a decision this week to release V23 at the state that we have right now. And that's what we probably do next week. Yeah, that's it. Thank you.
Thank you very much. Let us hear about the Rustport update.
Yep.
Anton?
Hey guys, Anton's here. And just as per usual, we worked on the same things as we were working before, because they take quite a lot of time. And as you can see, we're still working on porting all the changes from V23. We're still working on integrating Rust DPP that we've created some time ago into the rest of the platform. And I would talk a little bit about the actual updates that are happening, and they are detailed on the next slide. Can we go to the next slide, please? Yep. So this sprint, we've completed 6 more tasks regarding the V23 changes. So the last week, we've completed 10 out of 20 remaining tasks for V23. This week, we've completed another 6. So this brings us in a total 16 out of 20. And that means that hopefully by the end of the next sprint, we will actually be finished with porting V23 changes, unless we'll see some unexpected developments or bugs, which is, I think we've kept pretty good pace so far in that regard. So I think that estimation would be fair. We also continue to work on Rust DPP integration, which means integrating the Rust DPP into platform. We're working on those 2 tasks in parallel because we want to integrate the new Rust DPP into the whole platform as soon as possible. So right now we are working on integrating V22 DPP as much as possible into the platform code base. And then once V23 changes are finished, we want to for the rest of the stuff that is available in the DPP. We want to basically, this kind of saves us time making those two things in parallel. And so this sprint, we've done a lot of work on CI integration. We've made a lot of work on the FFI, which is a boundary, cross-platform boundary, because as you may know, most of the platform is written in JavaScript, while the actual protocol, well, the whole point of this team and this task is to port it to something more stable, which is Rust. And thus we need to make DPP to be able to communicate with the rest of the platform, with the rest of the JavaScript libraries, and that's what we are working on. Previously, we've made proof of concept that it generally works fine. And this sprint, we've stabilized API. We've stabilized how we cross this FFI boundary. We've made all the CI scripts, build scripts for different platforms, eliminated some bugs that we found in the process, and also we've made some bindings for the data structures we didn't make before. And that is what we are working right now. Now, as for the estimations on what we're going to do next, in the next sprint, if we all agree that the current infrastructural work is of an enough quality, we'll port the next sprint the rest of the data structures that are available in DPP. So far, we've ported identifier, metadata, identity, public keys. We still have documents and data contracts left, as well as state transitions. And that is what we are going to work on the next sprint. So tune in next time to see how this all is progressing. Thank you very much.
Thank you very much, Anton. And now let's go with the extra part, some of the meetup parts, and we will have people from here that are not usually participating in this review, but only because of we had a hackathon week. We are together, and they are going to show some of the work that are intertwined with platform work, or just showing some interesting things. All right, let's go and see what Odi has for us.
So, hello guys. So, I'm Odysseus. I will present to you the work done in core side. Can we go? All right, thank you. So, 10 days ago, the V18 hard fork was activated. So far, everything looks good. We have the new rotated LLMQ 6075 forming with the new rotation algorithm. The previous LLMQ 5060 are considered deprecated right now. And we have deterministic instance send logs happening using the new quorums. So regarding the work done since the fork, I've been working on upgrading the BLS library used in core. So basically, we are planning to use what is called the basic BLS scheme instead of the legacy one. So as you understand, this means that we are going to have a new fork since the scheme used for signing is going to be different. But turns out that only serialization of BLS objects are affected from that new BLS scheme. So for example, with once the fork is active, when a new masternode arrives and he sends pro-rectx transactions, the object will be mined into the chain using the new scheme. So in order to cover the deserialization of previous and older pro-rectx's on the chain, we need to version all kind of objects affected by this new scheme. Another example is obviously the final commitment of quorums. So another good news is that we're gonna have very soon, so probably next week, on testnet the version 18.1. And now I'm gonna pass to Konstantin, who will present the next feature that is currently in progress.
Hello, everyone. I'm Konstantin. I'm working in core team, and I'm implementing assets logs. Basically, in Dash platform to pay master nodes for storing data, potentially expensive operation, we need to use credits. And the problem what blockchain doesn't know anything about platform and need to integrate somehow credits and Dash between each other. For that is need mechanism what basically contains three components. First component is asset log transaction for locking Dash that currently use it on platform and converted to credits. Second thing is asset unlock transaction. It's withdrawal from platform back to Dash. And first thing is a credit pool. We need to know at every moment how much Dash is locked in platform and how much we can withdraw back from platform to coins. And what we can do. What's next? So I need to, particularly this week, I'm implementing credit pool, special transaction for asset logs, certain logs I implemented. And I plan to finish implementation credit pool anytime soon and looking for integration with platform team. That's all updates on current moment. Who's next?
All right, thank you very much, Konstantin. And we're moving forward with the iOS update, which is not a full update, but some things they wanted to share as well. So may I pass to Vladimir?
Yes, thanks, Balázs. So my name is Vladimir. I'm a senior iOS developer here in Dash Core Group. And mostly at the moment, I'm doing iOS SDK, which is used by our iOS applications. And also, as a part of it, I'm trying to write more Rust code that could be used for the SPV client in the future. Well, during this meetup, no. So we have been working for a long time on the implementation of Core 18. And after this release, we figured out that something didn't work quite well. So for example, on a large number of masternodes, sometimes quarters of the rotated quorums included the wrong masternodes. And this is basically in turn led to the formation of incorrect signature based on them and further to impossibility of BLS verification of this signature. Some difficulty was that the core of our SDK is written partially in Rust, which is in the current conditions leads to heavy debugging. And again, thanks to the fact that we met at the meetup, and I was able to work closely
with the core team. And I'd like to thank you guys. I was able to quickly get a lot of reference data for writing a good test, which includes a chain of several core info messages, quorum snapshots, and some another data needed for masternode list reconstruction. And as a result, we were able to iteratively find the problem and solve it, and also write a comprehensive test that will help to further support it. So this is basically it. Also, I would like to say big thanks Eric Britton from our Android team for helping me. That's it.
Thank you very much, Vladimir. Thank you. And may I pass to Pavel? Should I, or should we get back to?
Can people not hear him? You can speak through my computer.
All right, sorry. Yeah, my So I'm from UI team, or iOS team doing UI. We accomplished a couple of things here, and I will start with small things. We redesigned the navigation flow of the settings screen. And now it looks way better and like modern. I will also fix an annoying issue when the app can get logged just randomly while using. And the biggest thing is we are bringing the Coinbase integration into iOS as well. So it was released already on Android in August. And it was kind of tough story to bring it on Android first, and now we're based on the experience from Android team, we are bringing it onto iOS app. So that's going to be a huge thing. Yes, that's it for UI. Thanks.
Thank you.
Balash.
Thank you, Pavel.
Thanks, Pavel. And if people are wondering, yeah, we're all in, well, many of us are in the same co-working space here in Tbilisi. So, okay, so for me, I'm going to present two topics that we talked about this week. And I do want people to understand that these are not yet finalized. This was more of an introduction discussion. And so we don't really have the solution yet. We are working on it. We spent some time this week passing it to research team to get some actual numbers on a few, I mean, basically the cost to attack the network in dollars or Dash and things like that. So we're still, actually, the research team actually already gave that data, but it's been a pretty heavy week, so we haven't, really brought this conversation up yet. But again, the topic is basically, should platform be run on all nodes or just a subsection of nodes for our MVP release? Ideally, when we think about the later solution, we basically will have smart contracts, we'll have a sharded network, so not all execution needs to happen on all nodes, and we'll basically have like responsibility zones. But for right now, for our first release, we don't have a sharded network. So the real question is, how should we have platform running? And there are two main ways we can release. We can release with the platform running on all masternodes, and that's what we're calling the masternode solution. And the other solution we're calling the high performance masternode solution. And each one has some pros and some cons, and I'm going to be just explaining to you guys what each one is. We might even go to the network on this if it's if internally we decide to go for the high performance masternode solution, most likely we will verify that that is the solution that's also wanted by the masternode network. So with that, I'll talk about what each one really means. So the masternode solution is simple, like everybody runs platform, every masternode runs platform, and we allocate 50% of rewards to core, we allocate 50% of rewards to platform. And since everybody is running it, each section basically gets the same. I mean, you basically get half of your fees from platform, half of your fees from core if you're running both, and every node basically continues getting about the same amount of fees as they're getting right now. The high performance masternode solution is different. We would introduce a new type of masternode to the network, a masternode holding most likely 10,000 dash or 5,000 dash. We're not yet completely sure, but most likely 10,000 dash. And this would create a much smaller subsection of high performance nodes. They would act as normal nodes, except that they would have like 10 times more votes, for example, for governance. But they would be expected to be very quite powerful. When we think about what this would mean, if, for example, we allocated a certain amount of funds to these high performance node and a certain amount of funds to non-high performance nodes, you would actually start to get a market equilibrium where nodes would join this high performance because they would get more money. So if more fees would happen on one system, more would join, and you wouldn't basically be forced to join or to not join. It would just be a market decision of what gives you back the most rewards. And you could also take into account some other things, for example, that you maybe don't want to run platform. In fact, some people did reach out to me and say they really did not want to run platform, some community members. So in this case, in the solution of high performance masternodes, they would not have to. Also, for example, if we were to only run platform on, let's say you had 100 high performance masternodes later, the amount of data, the replication of data from platform would be much lower. You, instead of replicating on let's say we have 4,000 nodes in our network, it's pretty much average. Right now it's a little bit less because of V18, but you would have to replicate 1/40th less. So because the cost of storage is really determined about the replication factor, the fees in platform would be much, much less. We estimate, for example, like if something were to cost $2, instead it would cost something like 6 cents in the high performance masternode solution. So you get much, much lower fees. And I think that's the biggest advantage. The biggest disadvantage is that it's much less decentralized. Instead of having 5,000 nodes or 4,000 nodes that you can query platform to, you would only have 100. And there's this real big thing around like the more decentralized we are, the higher fees we have. So, and also the more, for this version, the more, the high performance masternode solution also will have a much higher transactions per second, basically because the nodes would be expected to be much stronger. So if you're running, a high performance masternode, your node should be around 10 times stronger than the normal masternode solution, which would in turn allow us to have a much higher transactions per second. So when we think about it, I do think that the solution with high performance gives more to average users because they would have lower fees, and we would also have a higher transactions per second. But being less decentralized is definitely a concern. So this, we haven't either come to a solution. This was more of an initial discussion. It's also very interesting to know what our community thinks on this, because it's going to probably be a very important topic over the next month or two. There's also in-between solutions. Like, for example, when I said, 10,000 Dash for a high performance masternode, there could also be, instead of 10,000, we go for 5,000, and this would double the amount of, high performance. They'd be half as performant, but we'd have more decentralization. So there's this ratio that we basically need to spend time figuring out of how low do we want our fees versus how much decentralization we want. And basically, it's now the time to start thinking about this. Okay, so I'll go on to the other topic that we discussed. The other topic is probably less interesting to people. It's around identity v2, and it's a much more technical topic. Currently, when we change the balance of an identity, we have to take the whole identity, deserialize all the data, change the balance, and then reserialize all the data. This is actually a pretty costly and expensive operation. Also, when you want to get information for an identity, we have to get all the information for an identity, including all the keys that identity has. If the identity were to have 1,000 keys, you'd have to get back all 1,000 keys for every identity that you're getting. This is kind of expensive for the network. So a solution would be to introduce a more structured approach with identity v2 using leveraging GroveDB. So basically, I'm not going to go too much in detail on how the system works here. This is kind of the tree structure, and basically we can decompose it in such a way that you could do specialized queries to the system where you would only get the keys that you're interested in. For example, you could get all the keys that are necessary for DashPay, or you can get the authentication key to verify that an identity had signed something correctly, and many other things. So your client would actually need to request much less data and in a queryable form. So this was the second topic. It's probably not as exciting or controversial as the first, but yeah, we needed to talk about it. Identity v2 also has been, very quick. A lot of it has already been implemented, so it won't take much more time. Okay.
All right. Thank you very much.
So now we're on to questions.
So one question I see unanswered is...
We had a question from...
Am I muted?
Ryan.
Can you hear me? You can't hear me?
Igor. It was nice browser extension demo. Will this have platform username features? So since I don't know that, Igor, you want to answer that one?
Yeah, sure, of course. I would say that yes, it definitely should have platform features, and it should follow actually the way the mobile apps following currently. If I'm not mistaken, they are doing the whole DashPay feature embedded into the wallet. But the truth is that in terms of reliability, security, performance, and feature richness, JavaScript wallet is not that advanced as mobile clients. And hence the top priority right now and for the upcoming couple months would be to make it rock solid in terms of operating with layer 1. And only after that, I think we could start thinking of something for platform related. But still, this is an open question. I made this app for purposes only, and maybe for personal usage. And if we decide to make in-house browser extension, I think we'll have more discussions about that, and etc. So yeah, that's it.
Thank you very much. Do you also want to answer the question, how is the coffee?
I did have 2 cups.
Is the coffee good?
I thought it was okay. Anybody else like coffee, dislike coffee?
Any objections of Georgian?
I think it's pretty good.
Okay.
Yeah.
So coffee is good as well. How much more time is not much more time?
Well, let's see. Checking how long we have it at. We currently have it at about a little over a week for implementation of Identity V2 for work left. Did you hear me?
Yes.
Okay, cool.
Yeah, thank you very much. And James Doe also asks, I thought the CEO was going to stop by today. Any plans on integration? Actually, Patrick was here just right before the... we are streaming this call from a Zoom call, and he was here right before we started. And he just has a busy schedule and overlapping meetings. And any plans on integration? I'm not sure.
I think he meant integration of the CEO into this call, like making the call bigger.
Yeah. Yes, we have ongoing discussions on it.
Okay, well, if there are no other things, I think, or other questions, we can call it a wrap.
All right. Then thank you, everybody. I would like to thank for you to join as viewers, as well as for the team. And I'm glad that we had a really nice an extended week in Georgia. And I would like to thank everybody, not only the work of the last period, but also the sacrifice, the time, the money you spent on and the sacrifice you made in terms of money and time just to get together, and hope we will have much more of this in the future. Thank you, everybody. See you in probably 2 weeks. Maybe we're getting back to the original schedule to Tuesdays. So see you then.
10 days.
See you. 10 days, exactly. Thank you very much.
Bye, guys.
Thank you. Bye-bye.